There we go.
Wait, people are out sick at home?
Yeah. I would
Huh.
assume you have to feel pretty bad to be out sick when you're at home.
Yeah.
Yeah.
Hey, Miss Schaefer, I'm feeling something coming on. I might need to go.
All right, so I've got this full screen. We'll see how this goes. Can you see the PowerPoint?
Yeah.
All I see is it says Grace Hanson.
Okay, so you're seeing, oh my gosh. All right, let me stop screen share and try it again. Desktop 2, share. All right, are you able to see chapter 12 behind the scenes?
Yes.
Okay, does everybody see that?
Yeah, I do.
Okay, good. All right, so this is a follow-up with networking and security in the business world. It may not be the most exciting, but you know, if you're interested in networking, it's good information, or if you're planning on trying to set up a network at home. I hate looking at the screen because I'd rather look at you guys, but I have to look at the PowerPoint. And oh good, it's working. So I want to let you know the plan for next week. Next week, I'm going to be traveling, and I'm not quite sure. I'm traveling all the way across country. So I'm not sure how the network connection will be as I'm traveling, since we're learning about networks here. I'll be depending on Wi-Fi and campgrounds, truck stops, and stuff like that. So I didn't want to go ahead and plan on having a live session, not knowing where I'll be and how the connection will be. So my plan is to just record the video for you in advance. I'll post it. So I'll post it. I don't know if I'll post it. I'll post it before Friday, but I don't know if I'll make it live. I might wait till Monday to make it live. So I'll just record what we're doing. We're doing behind the scenes with the internet. And this is where you do a final project to kind of pull everything together, and you'll actually do something. You're going to design a website. And the option will be Google Sites, because you have that as part of your account, or you can do others depending upon what you want to do and what your goal is. So I'll put a whole video together for that, and you can watch that. The other thing I like to do, since it's the week of Thanksgiving next week, which seems crazy to me, it just, the time's flying, but it's kind of a catch-up week. So if you're behind in things, that's the other reason to not do a live session, is to make the workload a little bit lighter, because you have access simulations, which can be hard for people if it's your first time doing access database type stuff. So that'll just give you a little extra time. If you're traveling for the holidays and you've got that time, you can watch the video when it's convenient for you. If you look in my IT lab and mastering, I did go ahead and open up the rest of the weeks. So we have, I guess, 4 weeks or 4 chapters of access. They're all open, and you can go ahead and start doing those whenever you want to do them. So if you want to try to knock them out, or you got extra time over the holiday break, then you can just sit there and do them all. But that's open for you to do them at your pace. The end of the semester will be here before we know it. It's like coming really fast. So just don't get behind. If you are behind, try to use the week of Thanksgiving. Hopefully you have a little bit of time off and you can get caught up. And remember, if there's any grades in the grade book that you don't like, go back and redo the assignment or make the assignment better. Send me a message in Canvas and let me know, and I'll regrade it. Okay, so if you don't have the grade that you want, go back in and work on it. I'd prefer not to have anything back from week, 1, 2, or 3, but the big projects, big grades, and the way to look at your grade book, if you haven't figured it out yet, or your grades, is that the assignments with more points count more. So focus on those first. So if your grade, most of you are doing wonderful, grades are excellent, but there's a few that have fallen a little bit behind. So if you're one of those people that's behind, look at the assignments with the most points, and those are the ones you want to do first. Of course, the ones with the most points take a little bit more time and work. They're not quick and easy to complete, but they're worth more points. And, you know, by the time you complete like 10 things that count 10 points, you can complete like 2 things that count 20 points and still be coming out ahead. Okay, so looking at this week, just looking at some of the advantages for businesses of installing a network. We've kind of already discussed a lot of those, but just dig into a little bit more. Looking at the topology of networks. So there's different types of networks there that we're going to be discussing. That kind of covers those. Look at wired and wireless transmission media and networks. So some of the different cables, and you've already had a little introduction to that. Network adapters, define a MAC address and what it does, and then the different network navigation devices. Explain why network operating systems are necessary for networks to function, and then look at the security threats to networks. Once again, like I said, we've kind of done all this, but it digs in a little bit deeper. And we do have 1 or 2 people interested in networking. Otherwise, I consider just skipping the chapter, right? Because there's a lot of review information. But we do have 1 or 2 people interested in maybe potentially doing networking as a career. So I didn't want to just completely skip it. All right, in the chat, if you want, in the chat window, if you have anything specific that you're interested in about networking, put that in the chat window. If you're not really interested, that's quite all right. Okay, so you can put, if you have questions or you have an area that you're interested in, just type that in. We'll try to look at them. Okay, so I have to go back and look at the objectives. Let me look at the objectives roll. Okay, so security threats. Okay. All right, excellent. Network print, okay. Kind of the whole cybersecurity thing, I guess, huh? Which is a growing field for sure. Okay, let me get to, okay, network architect. Once again, I think I shared most of this information before, so just resharing and just reminding, network architect salaries are on a national average around 137,000, with the Gilbert down here at the bottom, roughly 130,000. Now you can look that you're not going to make 130,000 right off the bat, but the low end is 73,000, which is still a really good salary. And then the high end's 194,000, which is a really good salary. Can't complain about any of that. Looking at the client server network, some of the basics, we're looking at advantages, which I think I said we talked about this before. It really enables you to share devices, resources, data, software, enhanced communication because you're all networked together. And then the networks are set up, part of the communication determines what type of network you want to actually set up, the topology you want to use. Disadvantages, it does require additional personnel. You have to have people that know what they're doing and people that are there to support it and keep it up and going. As you know from your own personal experiences, there's always problems with networks somewhere. And then it does require special equipment and software. Okay, just looking at just a basic network. This is a peer-to-peer. So you've got a couple. There's one that's centralized and one that's decentralized. So centralized puts, you've kind of have where everything's working together. It's kind of I don't know, I'm trying to think of the best way to explain it. You have like a center where everything's communicating together. Peer-to-peer is more direct, like from person to person, computer to computer. So not everything's as centralized, it's more direct. And peer-to-peer, I'm trying to think if peer-to-peer is even used much anymore. I'm sure it is in small offices or homes, but most of them are centralized. And then here's advantages of client server networks: scalability, efficient of data flow. Scalability, yeah, when you have a network, you can keep connecting and making it larger. the different types of networks. So you have what's called a LAN, that's a local area network. This is fewer users and typically a small geographical area. So if you're going to set up a network in your home, it would be a LAN. And it could be your community. It's typically like a business. So anytime you hear LAN, local area network, that's what it is. It's just a smaller network. You have a wide area network. This is many users over a big physical area. And this is more like your internet. So your internet's considered a wide area network. Intranet is a private network set up by a business. So that's when, sorry, if I'm talking too fast, somebody let me know because I get carried away. I talk fast. Intranet, this is when it's a private network set up for the business particularly. So it's not meant for anyone outside the business to access. It's completely for the business of that business, okay? The work and software and applications and everything that they're going to use within the business. Extranet is an area of internet used by certain people on the internet. So this is when they want to expand a little bit and be able to access, allow certain people access to the actual intranet. I know for us, you know, we typically get like a VPN where we can kind of tap in. So we're using an external network to tap into the internal network. All right, so VPN is what's next, virtual private networks. Use the public internet to build a secure private network. It's also referred to as tunneling. Like I said, you're connecting into the internet. And then key components, we talked about this before, but just kind of a quick review. You've got servers, the network topologies. I don't think we talked too much about, so that's one thing we're going to dig into in detail. And then transmission media, basically how does those data packets travel, network adapters, the network navigation devices, and network operating system. All of those we have discussed, at least introduced you to them. And this is just a visual of what a network would look like, just kind of a simple one. You have the laptop, so the laptop that you are using at home, it connects through a wireless connection. So there's a switch, which is then talking and communicating with a router. And then the router is connecting out to the internet. Once on the internet, then you're connecting to the router and the switch of the location that you're trying to access. So in this case, it's the manager's phone. So you can kind of see how it's flowing and connecting. All right, I hit too many buttons, I think. Looking at topology, so there are dedicated servers that fulfill a special function. This is just a graph of some of the different topologies and servers that fill those functions. So a lot of times there's a printer server. There's one specifically for applications, database, authentication, file, email, communications, web. The one that you probably use a good bit, you're not necessarily aware of it, is the print servers. And they will queue things up because a lot of times, you know, you can go in and you can cancel stuff out. That's why it's being all processed by a server. It's managing that. And then database servers, we talked about that when we were talking about databases. So there are servers that are just specifically for managing data. Authentication servers, we have those definitely with our campus, because if you notice, you can use your same login you can use for most of the application. So that's a single sign-on authentication, which allows you to log in with one login, but access everything you need to access. Now, we don't have everything like that in Maricopa, but there's a lot. There's email servers, file servers, communication servers. So just an example of all the different things that are being managed on these networks. It's a lot. All right, so Okay, looking at bus topology, these are computers that are connected in a sequence on a single cable. There's a lot of limitations with these, so that's why they're not used a lot. They're still used, but not as much as they were in the beginning, of course. But you have a lot of data collisions because you have data coming from two computers. They'll collide because it's a single cable and everything's trying to move along the same cable. The packets, the data gets broken into small packets, which if you have data collisions, some of those packets could get lost, and then that's when the information doesn't get to where it needs to get to. Passive technology, the nodes do nothing to help move the data. So the data is strictly moving across the cables, once the computer, so a node, if you don't remember correctly, or if you don't remember, a node is a computer that's sitting on the network. It could be a printer sitting on the network, but the nodes are not active in helping to pass information. It's instead just sitting there, and the cables, once the information's sent, it's going on its own. Terminators absorb signals. So at the end of the bus, we'll have a visual here in a second. At the end of the bus line, there is a terminator that has to absorb the signal so that it's not bouncing back and causing problems. Okay, the advantage is it's simple and it is low cost. All right, so here's a graphic of what this looks like. They give you an example that if the cable gets broken, then computer number 1 and computer number 2 are completely cut off from the rest of the network. Same thing, the end of the network's cut off from the beginning of the network. So there is, a slight problem with the bus topology if you do that. But if you notice, it's simple. Everything, it's called a bus topology because it's kind of like bus stops. All right, any questions about the bus topology? Does anybody, well, let's wait till we go through a couple more. Does anyone know if maybe at work, where you work, if they use a bus topology type network? You can just type in chat or speak, either one. Nobody knows? Okay. You probably wouldn't know unless you're involved in it or accidentally find out somehow. Okay, ring topology, it resembles a circuit. And ring topology, the way I always remember this one, it reminds me of the carousel. So in the old days, when you rode the carousel, there would be a ring that would hang on like the edge of the carousel, the canopy. And the idea was that as you rode by, you would try to grab the ring. So this is how I always remember what ring topology is. It's not exactly the same thing, but that's what helps me remember what it is. So there is a token. It's a special data packet. So I compare that to the ring that's hanging on the side of the carousel. And it's passed from computer to computer. It's an active topology in that the nodes actually help participate in the transmission of that data. So it's helping move the data around the ring, the network. Advantages, it provides a fair low allocation of resources and the performance is acceptable. Disadvantages, if one computer failure can bring down the network. So if you think about those Christmas light strings where if you pull out one light, the whole entire string of lights goes out. Okay, that's kind of like this. If one computer on the network fails, it could potentially take down the whole network. So here's an example of what this looks like. So you have the ring in the middle. I'm pointing like you can see me pointing, but there's a ring or circle in the middle and the token gets picked up by one computer, is passed around. It gets passed out to the computer number 2, and then it's passed back in, and then the ring goes around, and then the ring's passed out to the printer and then back out or back in. So you can see how that token just gets picked up and it gets passed around in order to do what it needs to do, what the instructions are to do. Okay, so a cable break, same like the bus topology. If the cable's broken, the ring's broken, or the circle is broken, so the network's broken, which means then everything goes down because it can no longer communicate with each other. All right, let me see what this says, see if it says anything different than what I already told you. Okay, so this example here, the token is being sent. I want to say the token's being sent by computer number 4. And what the transmission is, or what the instructions are, need to go to computer number 2. So when the token gets to computer number 2, it completes whatever the requirement was, whatever the data, whatever it was supposed to do. It is completed, and then it releases the token. The token goes back into the network to travel around. All right. Any questions about that?
No.
No questions? All right, how many people are finding this a little interesting? It's like all that behind the scenes stuff that when you use a computer, you don't realize all this stuff is happening, but it's kind of neat. That's why we talk, you know, people used to always say the current generation of kids are really good with technology. And what we've learned over the years is like, they're good with the user inside of technology, but they really have no clue what's going on the back end. So as long as everything's working correctly and they're just using a tool, everything's good. But as soon as you have to dig in, troubleshoot, you know, they don't understand what's going on the back end to be able to take it to the next level or solve the problem. Okay, so this is another topology. This one is a star. As you can imagine, it looks like a star or is a star shape. They're connected to a central communication device. And this is the most widely deployed. So this is used the most and probably what you work on. If you work at a business that has a network, it has the most flexibility for the lower price. And it uses carrier sense multiple access with collision detection. And in other words, there's not as much collision with the data traveling. And then there's jam signals that aids in addressing data collisions. All right, is this the same one? Yeah, so advantages: failure, one computer does not affect the rest of the network, so the whole network will not go down. It's easy to add on additional nodes, devices, computers, printers. Performance is acceptable as the network grows, and troubleshooting and repairs are easier. It's easier because it's not taking down the whole network, for one thing. Okay, so the disadvantage, they're saying it used to be a lot more expensive, but now it's not as expensive. So this is an example of a star. I guess if you think of a starfish with all the different arms, in this case, the different nodes, it's shown here that if there's a cable break, it's only going to take down that one device, not the whole entire network. So you can see where this network would definitely be better, especially if you're in a business where you can't have downtime. But each node, so your nodes are your printer, your server, your computer, is working off of that switch. So that switch manages the communication and gets the packets of information to the right device. All right. Any questions about the star topology? No questions? Okay, so I'm going to throw in some smart city network. This was not in the slide presentation. I've added it. It's some of the work we did last year with the CIS 105 group I had, because we kind of connected like the whole entire semester to smart city. And it's interesting what's going on with the smart city networks. They're taking the networking technology to a whole new level. So what this is called fog computing. And the idea of fog computing is there's this kind of middle layer to this network. And the middle layer is responsible for quickly processing data and getting information back out to the smart city itself. So if you look at this one, it's meant to be small data, which small data to us is still pretty big data unless you work in data. but it's looking at all of the devices that are connected to like agriculture. So all the sensors that are measuring water, measuring soil, measuring wind, energy, healthcare, transportation. So that transportation could be your stoplights, your street lights, sensors on the highway. It's all these different things where data is being collected. So data is being collected, let's say the streets. There's data being collected from temperature. And as soon as that temperature drops below 32, there's information being fed back out to maybe treat the roads so that it will not freeze. So there's different ways that happens. So it's just this quick exchange of data and information. Now in the bigger picture, so this is a bigger picture, that's why I said it's kind of a middle layer. You have what's called the edge layer. And this is the whole real-time data processing. So it's like that instant data. If we want to know the weather, we know it right away. So there's a sensor there reading the weather, but it's also reporting it out at the same time. Gateways, there might be some micro data storage. It's where the applications are running. So you got the sensors, the controllers, collecting information, somewhat managing that information, because the information that's being managed at that level could be information that's being sent right back out. It could be information that's processed real quickly within the small data layer, or it could be data that has to go all the way up to the cloud layer. So that's kind of the edge layer. Then we have the fog layer, which is the local network. That's that quick data analysis. So the quick pulling data in, processing, spitting it back out so the end user can see it. Or other sensors or controllers are making decisions based on the information it's getting. The top layer is the cloud layer. And this is the big data processing. So when we were talking about databases, that big data, this is where information is being pulled in, the data is being warehoused. It's not immediate decisions or analysis. It's data that's collected over the period of time. And this might be where there's like monthly reports being sent out, yearly reports, or analysis of monthly data. So that's really your big business analytics, the intelligence of the system. And then it shows, so over on the right side of this image, it shows how the bottom layer, the edge layer, is meant to be fast processing, where the higher up you go to the cloud, the longer it's going to take. So the response time is longer. All right, with this is another image, and it's just, I put this one in because it gives a couple images to further explain it. So the infrastructure's down at the bottom, that's that edge layer. You have the smart buildings, smart traffic, smart pipeline monitoring. And up in the fog layer, that's where you're going to have the edge computing nodes, the sensing networks and critical infrastructures, the intermediate computing nodes. So you got a couple different layers of computing nodes. And then what type of information, and then the data centers. So just another kind of image there to help you out. So, okay, I learned something. Do you guys see, well, I guess it would just be those of you in Gilbert. They tend to throw out a paper. Let me see, I got it right here. This paper here, the Gilbert Sun News. And did anybody read the one that we just got, the Gilbert Sun News, and reading about how they're analyzing wastewater? Anybody read that one? I don't know if I got the article. Let me see. I don't have the current one here. I threw it away. Nobody read it? Okay, so what they're doing with analyzing wastewater, they are, of course, using our wastewater network. Okay, so this is a use of a network. It just happens to be the poop network. And what they're doing with it they're collecting samples from wastewater, and they're kind of doing it in based on it's based on the wastewater stations, which I'm not real clear. I would have to go on the Gilbert's website and figure out where that exactly is. But there's different waste centers, and they're collecting wastewater. They're sending it to ASU. They're evaluating it based on COVID. So they're testing the wastewater to determine where COVID outbreaks are starting to happen. Because a lot of times they know by our poop who's got COVID before we realize we have COVID. So apparently they can detect it in the poop before you have been tested or even know you have COVID. So they're using the wastewater to actually start mapping out and determining where the outbreaks are going to be. I know it's crazy in April. And in some ways it scares me because they can actually, it is getting weird. They can narrow it down to communities. And I'm thinking down to neighborhoods. They're not narrowing it down to houses, which they probably could if they really wanted to, but they won't. They're just doing it by neighborhood or smaller communities. And once they know, they're sharing the information. I don't know if it's public where we can just get it, because Gilbert shares a lot of data on their website that you can just get to. You can't narrow it down to a household, but you can narrow it down to kind of geographical area. And that data is typically available. So they're sharing that information with schools. And that's one way they're determining what schools to shut down, which, or to put online, and even businesses and communities. So the next time you go to poop in the toilet, you'll have something to think about, or you might be pooping in your backyard now, right? And just think about how that information could be misused. That's what's scary when you start thinking about this whole Internet of Things. And I mean, this isn't even an Internet of Things thing. It's your wastewater system that they're tapping into. I heard from somebody that the president, and I think it was on the airplane, when they fly on the airplane, their wastewater is collected and dumped somewhere else because terrorists and other people can analyze the waste of the president and determine like what type of medical problems they have. So then that can be a way that they try to kill or attack the president. I don't know if that's true. I heard that, I don't know, 5-10 years back, but I could see where after hearing about this, I'm like, oh, I bet it is true. I bet they don't let the president's wastewater get anywhere that someone could get to it to analyze it. All right, so that's just an example of how networks can be tapped into and what can be done with them. All right, what I want you to do now, thinking about your own, and let's just put this in the chat, or would you rather do a breakout? Do you want to do a breakout and discuss it? Or you just want to put your answers in chat? Okay, I got one vote for chat. Chat, okay. Chat will be quicker because today's actually gonna be fairly quick. Okay, chat's okay. So what I want you to do, enter in chat. If, let's not say if, because smart cities are growing. Gilbert's on they're doing stuff already. But as smart city networks grow, what could potentially make your life better if they added, if stuff was added into the network, or if things were, how could a smart city make your life better? And I'm trying to think of some good examples. So one is with lights. We've seen that as it gets dark, it senses as dark, the lights automatically come on. So no one's having to flip a switch on to turn on the street lights. Watering, it's always funny, right? We're required to water our grass or water our plants, but it's really entertaining when you walk around and it's raining and the sprinklers are running. Okay, that's an example of where a smart technology, controllers and sensors would make sense, because you don't want to water the grass when it's already raining, especially if it happens to be during one of our 100-year or 50-year floods. Well, it's a requirement if you live in a neighborhood with an HOA. that you have to water your plants, that they have to be on a drip line and automatically watered daily. If you're on property that doesn't have HOA, then it's not required. But yeah, that's an example. The greenways, that's one of the areas where it'll be raining and they're watering the grass. And it's like, why are we wasting water when it's raining? But that could be where a sensor is set up. It senses that it's raining. It knows by the moisture in the air or moisture in the ground for that matter, and it will not run the sprinklers during that time. Okay, so think about your own needs. Think about driving when you're driving, riding a bicycle, riding horses, whatever it is. And then just finding a girl that can deal with my crap. What does that mean, Garrett?
Well, I was just making a joke because we were talking about how they could analyze the president's poop or whatever. So just finding somebody that was compatible isn't too far off. I just thought that was funny.
Yeah, that's true. And of course, there's all types of technology being used for that. Just, I guess with Smart City, there could be a network. Well, they're doing it with the apps already. I'm trying to think if there's someone compatible that happens to be close to you at the moment. Because you know how with Waze, when you're driving, you can see the different drivers.
Yeah.
But I think doesn't one of the apps do that already? Where
I have no idea. I don't use apps.
Yeah, I think some of those like Tinder apps or something that it'll match you up with people close to you. I don't know. But yeah, that could work. That would be an example. All right, who else has an example? I know my friend, it was before I was married. So this was almost 20 years ago. I went to South Korea to visit my friend in South Korea. And believe it or not, she was actually living in a Trump Tower, which was kind of interesting. And it was pretty, like South Korea, the building was already high tech compared to what was what I was exposed to in the US. But she could go from her apartment, she had a display panel where she could call an elevator. So whenever she was ready to catch an elevator, she would just call the elevator. It would let her know exactly what floor it was on and when it was getting to her floor so she could go out. That way she didn't have to go out in the hall, push the button and stand there and wait on the elevator. She could just call it and then it would be there when she got out. That's kind of common now. I know we can do that here in the US, but like 20 years ago, that wasn't really a thing here. Okay, improvement of power roads, traffic lights. Yeah, I would agree with that. So the traffic lights, I know they have the cameras and the sensors on them. And ideally, some of the lights are supposed to change. When someone pulls up, it's monitoring. But they've got a long ways to go because I know you could still be sitting in I think of Power Road because I've done it before. You're just sitting there and you're waiting and it's like, okay, why do I have a red light? There's like nobody here. I'm the only one at the light. Okay, telling the wait times in drive-through, that's good. Just like Disneyland, right? They can tell you what the wait times are for the rides. So if you can see the wait times for drive-throughs, that would be helpful. All right, possibly something more street traffic control. There are a few stoplights near me that take an eternity. Yeah, I agree, Kyle. Oh my gosh, you waited 15 minutes to make a left turn? I think I would have ran the light. It's like, I'll wait 5 minutes. I'm not waiting 15 minutes. I'll either go a different way or.
But there were cars in front of me.
Oh, you were stuck.
Yeah, I had to get to school and I was just sitting in a turn lane for 15 minutes. I counted the minutes.
Oh, man.
I was late.
Wow. Okay, so a couple other examples of smart cities. One example could be, and I'm making this up. I don't know. I don't know if it's a thing or going to be a thing. But one is, let's say there's sensors on the sidewalks, and when someone drops a piece of trash that does not get picked up, there could be a sensor, and maybe it's a camera sensor, maybe it's actual sensor in the sidewalk. I don't know. But it then triggers a robot to come and actually sweep the trash up. So that could be an example of a smart city. I know with smart cities, they're looking at heating sidewalks. So there's a smart city in Canada that they've been working on and Google's involved with. I don't know where it's at because there was a lot of debate around that. And yeah, like the movie Robots, they're planning on having sensors in the sidewalks. So if they're going to freeze, they know to heat the sidewalks in order to melt the ice. I don't know if they're planning on cooling them or just because in Phoenix, I could help if they could cool them, keep the temperature down in the summer. Let's see, what's some of the others? I know there's a lot happening around weather, water. There's a lot with those. I'm trying to think. I can't think of the other stuff right now. But those are just examples of how networks are being used to actually make lives better. Now you can also look at the negative side. So when you get into the whole ethical side of things, it's like, where's that data going? Who sees the data? Who's managing the data? Who might misuse the data? That's the really scary part, is how that information could be misused. So you definitely want to keep your eye on what's happening with smart cities. Anytime there's something with voting, make sure you educate yourselves and you get out and vote on those. I haven't really seen anything, but keep an eye because that stuff's going to come up. Okay. The next slide. So this is just, it says network architect at the top. Ignore that. I forgot to change that out. But what we're talking about with the smart cities, the networks, is also the Internet of Things. So IoT is Internet of Things. And these are future jobs. They say future jobs, but some of these are already in place and they're already learning. So there's professional tribber. I don't know what that is. Platform developers, that's going to keep happening because a lot of that smart city stuff, our devices in our hands are going to be talking to them. Data scientists going to be huge because all the data that they're collecting. But you can look at the other, there's your robotic specialists. There's going to be a lot more of that. Virtual reality design, that's where you're coming in with not just virtual reality, but the augmented reality where they're creating the glasses and you're going to be able to have information overlaid over your actual environment. Machine learning scientists. So these are all different jobs that are going to be coming. So once again, if you're not set on a career and you're still wondering what you might want to do, these are some jobs that are growing and coming. All right, so looking at transmission media. So how does all this information get transferred? We've got wired, wireless, and then the corporate networks use both. In a lot of cases, we're using both every day too, because in our homes, we probably have a wireless network set up, but then we're connected, that taps into the wired network to get out to the internet. Okay, with cables, when you're looking at cables, there's a couple different things to think about. If you remember, I sent you one cable to kind of play with, but different considerations when you're setting up a network. When you determine your cable, how long does the cable need to be to make the network all connect? What's the bandwidth? So how fast is it going to transfer information? The bend radius, how much do you need it to be able to bend? The cable cost, installation cost, so money's always a consideration. And then interference, how much built-in stuff do you need so that there's not interference on the cable wires? There's different sources of interference, electromagnetic and radio frequency. Our favorite from the old days when I used to work closely with the network person in our school building, and our favorite, and even my husband, when he did networking, the favorite was somebody would call us down and it's like, my network's not, my computer's like all jerky and making, there's something wrong. It's not working. And of course it's interference. Well, you come to find out they would have a little heater sitting underneath their desk right beside the computer. So there was interference coming from the heater that they had running under their desk with the computer. All right, and there's a graph there that kind of shows some of that information. Okay, so the first type of wire, twisted pair cable. These are copper wires that are twisted around each other within the plastic covering, and it's unshielded, has no foil shielding. So foil shielding helps with interference to prevent it. So the wires themselves do not have the foil, but the outer coating does have the foil. And the wires are twisted. That helps with the interference too. There's the coaxial cable. Most of you are probably familiar with this if you've ever had cable in your home. I know that's not as popular now. Even so, yeah, not as popular. But these are still used when there's heavy electrical interference. You can kind of see how it's made. You got the copper wire in the middle, plastic insulation around that. Then you have a braided metal shielding, and then the plastic jacket. All right, yes. There is fiber optic, and if you're lucky, this is what you have coming into your home right now, but it's composed of glass fiber. So the way the information travels is actually through that glass fiber, and the protective layer of glass or plastic to protect it. So it might have another layer that could also be glass, or it might be plastic. And then it also has the outer jacket. Obviously, if you're using glass, you need something to protect it. And the transmission is only in one direction. All right, the business wireless networks, it's similar to home networks. You have your wireless access points, and that's so that you can get additional coverage. And then most businesses do use a combination of wired or wireless. That's definitely the case with Maricopa, because a lot of our lab computers are hardwired. But if students bring in wireless devices, you're also able to hit the network. So there's both networks going. And this is just a graphic, a layout of what that looks like. So you see some are the desktop computer's hardwired, the server is, but the laptop computer and the smartphone's not. And that's kind of typical. Okay, looking at network adapters, navigation devices. These are devices that perform specific tasks that help the different nodes on the network communicate. There's 3 critical functions. One, to generate high power signals. So if the network's kind of big, or there's nodes further away from the wireless contact, then it'll generate high power signals. It can break data into packets, and it's not just wireless either, it's any network. Break data into packets. That allows the information to be transferred quicker, and then act as gatekeepers for information. And then here's just an example of what that looks like. So your computer, if you're connecting to the network at all, whether it's wireless or hardwired, you have a network interface card, which is also called a NIC card. And then it kind of gives you an idea of what this response packet looks like. So sending a packet, receiving a packet, and then how that interacts with the server. A lot of times when you look at the network and packets, just think about a letter in the mail. Okay, it's kind of the same idea. You're sticking a letter in the mail to mail your friend, and you're going to send it to them. Hopefully they respond back. They reply with a letter. All right, MAC address. This is your media access control address. It's a 6 2-position character. The first 3 sets specify the manufacturer. The second set makes up a unique address. And the numbers are allocated by the Institute of Electrical and Electronics Engineers. It's not the same as an IP address, so it's different than an IP address. Carl said he had to remove his NIC card. Oh, so you could fit in a GPU? Yeah, I can see where the GPU is more important, depending on what you're doing, but okay. Other devices that are on the network, we've already referenced them, but this is just a little bit more information. So the switch rebroadcasts data to the appropriate network node. So it's a way to put that signal out there a little bit further. The bridge sends data between the different collision domains. So you may have, okay, they don't put that in the image. Okay, so you could have different domains, and that's just helping to send the information so that you're not having those collisions. And then the router sends information between two separate networks or two different networks. So when you see switch, router, bridge, that'll give you an idea of what those, it's all to connect information or send information. Network operating system. I think we've covered all this really. It needs to be installed on each client and server. It's designed to facilitate communication, peer-to-peer software built into Windows, and TCP/IP is the standard networking protocol. I know we touched on those. Okay, sources of security threats. So this is what several of you were interested in knowing more about. Security threats, probably one of the #1 issues is human errors and mistakes. That happens all the time. Malicious human activity. And then the other one's natural events and disasters. Authentication is used to screen users, and that you're used to that, right? And if you do the double authentication, which a lot of applications are starting to do now. I know even with Facebook, I set up on my Facebook, so you have to do double authentication. So I'll log in, but then it also sends a number security code to my phone that I then have to enter in order to log into Facebook. There's brute force attack. So what brute force attack is that someone is trying to log in as you, and they just keep trying and trying and trying until they get it. So that's the idea. They're trying to guess the password to get into your account. So that's what a brute force is. Okay, so there's different ways that you can provide access privileges. So basically, how do you keep people out of the network that you don't want into the network? There's different ways that we're doing this. It gives an example, the access card reader. So you have a card you got to scan to get in. Retinal scanning with the eye, fingerprint with the palm and scanning, and facial recognition. We're seeing a lot of these in smartphones already. Does anyone have the facial recognition on your phone? Have you been doing that? I'm not sure if that's just iPhone or if there's been other ones.
I have it on my iPhone.
Does it work pretty well?
Yeah, it does. It does. And I have it set to a certain angle on my face.
Mm-hmm.
So it's not like a direct face, it's like a side face. So say if someone wants to like get into my phone, they have to use the side of my face. They can't like pretend to use my whole face.
Oh, okay. So it would be harder because
Yeah.
I think at one point they were saying people could take a portrait or a picture of a person.
Yeah.
Yeah.
Yeah, but I made it tougher.
Yeah. I know with my computer now, I use fingerprint a lot on my new computer because it's got the fingerprint recognition. I really like that because that makes it quick and easy to log in.
Yeah, it does.
Yeah. All right. Anyone use retinal scanning anywhere? Any place you work that does retinal scanning? The one, so it's not retinal scanning, but if you go to Disneyland, you know how they take your picture? So every time, it doesn't matter what ticket you have, they take your picture. They're actually, so what they do, one of the things they do is they're measuring the distance between your eyes, because they say that not too many people have the exact same distance between their eyes. And I'm not sure what part of the eye, if they're measuring, I don't know what part of the eye, but there's a distance between your eyes that get measured. They automatically scan that against a what do you call it? A child molester database. And if you go into Disneyland, they won't necessarily deny you access, but what they'll do, they'll have people following you around the whole time you're in there if you're a child molester. So it's pretty neat, the stuff they do. You know, in some ways it makes you wonder, yeah. It's good as a parent, right? If you have kids, to know that they're checking that and they follow around. So I actually talked to people that they were, I think they were police officers in Nevada, maybe Vegas, but they said that Disneyland, or Disney in general, has an awesome security training program. A lot of businesses send people to Disney's training program. That's how I learned the information. We were standing in line talking to them one year we were there. So they get training, but they said that they have so many security people on site, and most of the time you don't know who they are because they're dressed like normal people, and that they keep an eye on people. So if you have a child molester coming to the park, they're being tracked the whole time. And if you do anything, I guess, out of the ordinary, you're being tracked, you know, if you throw up a red flag. But the other experience was too, they were talking about with kids, when kids disappear in Disneyland, they're like on it right away. Like they have people all over the park and they're automatically like looking for them. Because she gave an example, somebody lost their child. They got separated from their child while they were in the park. And she was in, so they have like 2 centers where you can go for looking for, they're like child centers. There's like one in each park, and they happen to be there filling out paperwork, I guess, for a missing child. And before the mom even got through the paperwork, they had already retrieved their child and had them back to them. So that's how quick they got on top of it, was able to return a missing child. Because I used to be one of those parents too, where when you go to Disneyland, because my one boy, I used to say he was a runner. Like anytime he got upset, he would just take off running. So I always panic, like especially in Disneyland, because there's so many people. It's like, oh my gosh, if he runs off, I'll never find him. Well, after I learned that, I relaxed a little bit. It's like, oh, okay. You know, to know someone was filling out paperwork and they retrieved the child, found them before they ever got the paperwork done. It's like, that's pretty reassuring. So anyway, so there's all types of security, and just think about the network that Disney has. By the way, my goal is to work at one of the Disney parks when I retire. I'm not going to work on the security side of things. At least that's not my plan. I want to work with the photographers that take pictures of the kids with the characters. So I think that'll be fun. But that's one of my goals. I want to get on the inside of Disney and work for Disney a little bit after I retire. So, anything else? Nope, nothing else with that screen. Any questions? Okay, multi-factor authentication requires 2 of the 3 factors that are listed here. So it gives an example of something you are, something you have, something you know. So I'm sure you're used to security questions. So a lot of times they have you put in information and answers to 2 or 3 or 4. I think some of them are even 4 or 5 security questions. So this is just multi-factor authentication. I know with like alarm systems at home, you know, if the alarm goes off, you have to have a number. So there's different ways that they're doing this multi-factor authentication. Okay, firewalls can be be composed of software or hardware, and we'll see a graph of this in a second. But packet screening, it's an external screening router that examines data coming in. So this is one way that it's checking information before it ever even gets on the business side of the firewall. There's, all right, let me go to the graphic here. This will be better so you can see it. Somebody have a question? No. Okay. So with this, okay, so you see the packets on the outside of the brick wall. The brick wall is symbolizing the firewall. And then information will get rejected before it ever comes in. You have that screening router that determines whether the information coming in is going to be accepted or rejected. And then there's a proxy server that it passes through. And then you have an internal screening router. So there's a lot of like security things to check for before information ever gets to a computer that an employee is using. And of course, all this has to be set up. It's not natural. That's where a network engineer comes in handy, or network folks, where they can actually get all this programmed and software installed, the hardware installed to have it set up. Okay, so that is it for networking. Let me go to, let me get out of this. And let's just go to, all right, I'm trying to find my, yep, here we go. Okay, I'm just going to the overview. So this week, we are pretty much finished. So this week was quick because there was a lot of review, and you have simulations and everything to work on. So I'm not worried that we're ending early. Hopefully you have the gift of time and you could sit and work on some of these simulations. But make sure you read the chapter 12 behind the scenes. There is the chapter 12 quiz. And then you have access simulation training number 1 and access chapter 1 simulation exam. So make sure you do those. Like I said, I've opened up all of the other simulations. There's going to be 4 access simulations, so you can get working on those. The only other project you're going to have is for a website. If you want to, you can start thinking about that. Like I said, I'll put a video together. You're going to do a website. Google Sites is already part of your Gmail, your Google Suite, and everything that you use for Maricopa. So if you don't need the website for anything in particular, I'm going to walk you through on how to do Google Sites. But if you have a business and you actually want to set it up on the outside, you might want to use something like Wix.com or WordPress. I can't remember if it's WordPress.com or WordPress.org. But those are different options. So just be thinking about that. And then as far as the website, you're going to be doing something that you're interested in, but you can also kind of showcase what you learned in the course. So I'll share more of that in the video and get some details to you for that. All right. Any questions? Any questions as far as assignment for this week, or any questions about the networking information we covered?
No.
No? Okay. If there's no questions, you're actually good to go. So tonight's a short class. If you want to ask questions, hang around.
I'll hang around. I have a question that doesn't pertain necessarily to the class, but
Okay, let me stop. Don't ask yet. Let me stop the recording as soon as I can find the button for that.